Ever wondered how your computer understands your commands? This magic is brought to life through the use of programming languages. Think of it as the special language you use to tell your computer what to do. Just as we use language to express our thoughts and ideas, programmers use programming languages to communicate instructions to computers. It's a structured, formalized method that allows us to command a machine to perform specific tasks or computations. So, whether it's as simple as printing "Hello World" on your screen, or as complex as simulating a virtual reality environment, it all boils down to a series of commands in a programming language. Programming languages are not just a tool, but an art form that opens up a world of possibilities. A world where we can create, innovate, and solve problems. In essence, programming languages are the bridge between human thought and machine execution. Programming languages, like human languages, have their own unique structure and rules. This structure is made up of syntax and semantics. Syntax is like the grammar of a programming language. It's the set of rules that governs how we arrange symbols, keywords, and expressions to form a valid program. If you've ever had a friend correct your grammar when you're speaking, it's the same idea. A compiler or interpreter is that friend in programming, making sure you're following the syntax rules of the language. Semantics, on the other hand, is about the meaning of these arrangements. Once you've written a syntactically correct program, semantics is what defines how that program behaves or operates. Imagine you're telling a joke. You've got your grammar down, but if the punchline doesn't make sense, the joke falls flat. That's semantics. In programming, if your semantics are off, your program might compile but not do what you intended. Now let's talk about data types and variables. These are like the vocabulary of a programming language. A data type specifies the type of data a variable can hold. For example, an integer data type holds whole numbers, a string data type holds sequences of characters, and a float data type holds numbers with decimal points. Think of data types as different baskets you can put your data into. Variables are named storage locations that hold the values or references to data. Imagine you're baking a cake. You have different ingredients: flour, sugar, eggs, and so on. You can think of these ingredients as data types, and the bowls you put them in as variables. The bowls' variables hold the ingredients, data types, and the labels on the bowls, variable names, let you know which ingredient is in which bowl. So, syntax and semantics make up the grammar of a programming language, while data types and variables are like the vocabulary. In the next scene, we'll delve deeper into the world of programming languages, exploring control flow and functions. Stay tuned! Now that we've covered the basics, let's delve deeper into the architecture of programming languages. Let's start with control flow, the roadmap of a program. It's what guides the execution of a program from start to finish, like a GPS navigating through code. Control structures, such as loops, conditionals, and branches, are the traffic signs, determining the direction of the journey. For instance, a loop will keep the program circling through a block of code until a specific condition is met, like endlessly circling a roundabout until the right exit appears. Next up, we have functions and procedures, the building blocks of our code. A function is an encapsulated piece of code designed to perform a specific task. Think of it as a mini-program within your program, a specialist called upon when needed. On the other hand, a procedure is similar to a function, but it doesn't return a value. It's like a worker who does the job but doesn't report back. Finally, we arrive at object-oriented programming, the blueprint for creating complex structures. Here we use classes and objects to organize our code. A class is a blueprint, defining the properties and behaviors of an object. An object, on the other hand, is an instance of a class, like a building constructed from the blueprint. In object-oriented programming, we also have the concepts of inheritance and polymorphism. Inheritance allows a class to acquire the properties and methods of another class, just like a child inheriting traits from a parent. Polymorphism, on the other hand, allows objects to take on many forms, much like an actor playing different roles. So in essence, control flow is the roadmap guiding us through the journey of a program. Functions and procedures are the workers, performing tasks along the way. And object-oriented programming is the grand design, the blueprint that allows us to create complex, reusable structures from simple building blocks. Think of control flow as the roadmap of a program, and functions and procedures as the building blocks. Meanwhile, object-oriented programming is like a blueprint for creating complex structures. Just as there are many languages in the world, there are also many types of programming languages. This is our starting point as we delve into the fascinating world of programming languages and their classifications. Let's start with the first major category: imperative versus declarative languages. Imperative languages are all about control. They're like a detailed recipe where you, the chef, dictate exactly how the computer should perform each step. You're in the driver's seat, giving direct commands. Famous examples of imperative languages include the C family, like C and C++, where you specify how to perform a task through a sequence of statements. On the flip side, we have declarative languages. In declarative languages, you describe what you want, but you don't give explicit instructions on how to get it. It's like ordering at a restaurant. You tell the waiter what you want and the kitchen does the rest. SQL, used for managing data in databases, and HTML, CSS, used for designing websites, are examples of declarative languages. Now let's move on to another classification: procedural versus object-oriented versus functional languages. Procedural languages are like a toolbox. They organize code into procedures or functions, each doing a specific task. This makes them great for structured programming. Think of languages like C and Pascal as your go-to procedural languages. Object-oriented languages, on the other hand, model the world in terms of objects and their interactions. It's like creating a mini-universe within your code, where each object has its own properties and behaviors. Languages like Java, C#, and Python fall into this category. Finally, we have functional languages. These languages treat computation as the evaluation of mathematical functions. They emphasize immutability and the use of pure functions, making them a favorite among mathematicians and data scientists. Haskell and Lisp are prime examples of functional languages. So there you have it, a quick tour of programming language classifications. Whether you're giving direct commands, describing what you want, or using mathematical logic, there's a programming language for you. The world of programming languages doesn't end there, though. There's another way to categorize them: compiled versus interpreted languages. In compiled languages such as C, C++, and Rust, the code you write is translated into machine code before it's executed. This means that the computer can run the program directly, without needing to understand the original programming language. This translation process happens all at once, turning your entire program into a set of machine instructions. On the other hand, interpreted languages like Python and JavaScript are executed line by an interpreter at runtime. This means that the computer reads and executes each line of the program in order, one at a time. Because of this, interpreted languages can provide more flexibility and ease of use, especially for beginners. Now, let's talk about paradigm-based classification. Imperative languages such as C and C++ focus on specifying how to achieve a goal step by step. They're like a detailed recipe telling the computer exactly what to do and when to do it. On the flip side, declarative languages describe what the program should accomplish without specifying the exact steps. They're more like ordering a meal at a restaurant. You tell the waiter what you want, and they figure out how to make it happen. Languages like SQL, which is used for databases, and HTML, CSS, used for web design, fall into this category. Finally, there are multi-paradigm languages that support more than one programming style. Python and JavaScript, for instance, can support both procedural and object-oriented programming. This versatility can be a boon to programmers, allowing them to choose the most effective approach for each task at hand. So whether you prefer to prepare your program ahead of time or take things line by line, there's a programming language to suit your style. So, we've taken a whirlwind tour of the world of programming languages. We've seen how they act as the bridge between humans and machines, enabling us to communicate instructions in a structured and understandable manner. We've explored the key concepts that underpin these languages, like syntax and semantics, data types and variables, control structures, and the principles of object-oriented programming. We've also dived into the diverse ways in which these languages can be classified, from the procedural to the object-oriented, the imperative to the declarative, and the compiled to the interpreted. The beauty of programming languages lies in their variety and versatility. Each one has its strengths and weaknesses and can be chosen based on the specific needs of a task or project. As we've seen, there's a whole universe of programming languages out there waiting for you to explore. Remember, the best programming language is the one that best serves your needs and goals. Happy coding!